Here we have a few problems referring to the multiplicity of polynomials. So quickly let's review the theorem. If a polynomial function f has a real zero c of odd multiplicity, then the graph of f crosses the x-axis at c, 0, and the value of f changes signs at c equals c. If a polynomial function f has a real zero c of even multiplicity, then the graph of f does not cross the x-axis at c equals 0. And the value of f does not change sign at x equals c. So if we have some binomial and its power is odd, that means that the polynomial is actually going to cross at that 0. Okay, so it's going to go from the negative part of the range into the positive part of the range. That's what it means by it changes sign. Okay, so for example, in this function that I have here on the screen, f of x equals, in parentheses, x minus 2 to the power of 3, and then x plus 1 to the power of 2, right? For the x minus 2 to the third power, this 0 has an odd multiplicity. So if we look at its graph, at positive 2, it actually crosses, right? So at this point here, it crosses the x-axis. That's what it means by it changes sign and crosses the x-axis. Now, if you have an even power for your 0, that means it will only touch the x-axis but not cross it, right? So again, back to our function that I have here on the screen, the x plus 1 to the second power, because this 0 has a power of 2, meaning it's an even power, we can see that at negative 1, it comes and it touches it, but it doesn't cross it, right? It comes up, it curves, touches negative 1, and then goes back down. So it doesn't actually change its sign, meaning it stays in the negative range. So here I have another example. They give me the function where x plus 2 is to the power of 3 and x minus 1 is to the power of 2. So first, I notice that the x plus 2, 0, has an odd degree, right? So the 3 is an odd degree, which means that it will cross the x-axis, right? So on my graph, at negative 2, I know it's going to be crossing that x-axis, either going downward or going upward. We don't know quite yet. Then I look at the other 0, x minus 1 is to the second degree, right? So that is an even power, which means it's only going to touch the x-axis. So at positive 1, the polynomial is going to come up, and it's either going to touch it that way, or it's going to touch it going up way. Okay? Now, how do we know which way it's going? Well, that would be according to what power this actual function is, right? So if I know that the first 0 is to the power of 3 and the second 0 is to the power of 2, then I know that the leading coefficient for this function in general is going to be x to the 5th degree, right? Because we know if we were to FOIL it all out, x to the third power, right, plus another x to the second power would give me x to the 5th power. Now, the 5th power tells me that the ends of this polynomial are going to end up in two opposite directions, and because it's a number greater than 1, right, a positive, that means I'm going to have one end going up into the first quadrant, and then I'm going to have the second end going down into the third quadrant. So if I go back to my graph, I can approximate that the polynomial is going to probably look something like this, right? So it's going to come down, touch at positive 1, go back up somewhere, right, and then cross again at negative 2. So the sketch of this graph would kind of look like that. If we wanted an actual perfect polynomial, we would plug it into our graphing calculator and see what it comes out with, which you're welcome to do.